Very good morning to all of you. In the previous class, we have completed the kinematics of flow or fluid kinematics in unit number 2. In that, we have seen the Eulerian and the Lagrangian approach. Also, uh, kinetics of flow means your fluid force is not causing the flow, or the force is not considering for the cause of flow. But in the fluid dynamics, we are considering the force component, and it means that there is motion and force causing flow. In fluid kinematics, velocity and acceleration, and we are neglecting the force causing flow. So before going for the fluid dynamics, just we will see the definition. It is a branch of science that deals with the motion of fluid considering forces causing the motion, and the dynamic behavior of fluid flow is analyzed by the Newton's second law of motion, which relates the acceleration with the forces. You know that Newton's second law of motion is nothing but force is equal to mass into acceleration, that is ma. In that case, we are considering that the dynamic, we are considering that force causing the flow. The motion which relates the acceleration with the forces and the fluid is assumed to be incompressible and non-viscous. The fluid is assumed to be incompressible, means that fluid is not compressible and non-viscous fluid. We are considering the fluid dynamic, the dynamic of fluid. Okay. So in fluid dynamics, the equation of fluid dynamics describes that in a steady state process, the rate at which mass leaves the system is equal to the rate at which the mass enters into the system. Okay. So in dynamic of flow, the continuing equation describes that steady state process, in steady state process, the rate at which mass leaves the system is equal to the rate at which mass enters into the system. So before going for the dynamic study, we will see the law of conservation of mass. So in physics or in chemistry, the law of conservation of mass or principle of mass conservation is stated that if the system closed to all transfers of matter and energy, the mass of the system must remain constant over time. The mass of the system must remain constant over a time, as the system mass cannot change, so quantity can neither be added nor be removed. Therefore, the quantity of mass is conserved over a time. Therefore, the quantity of mass conserved over a time. You know this, the reaction CH4 methane plus 2O2. So the CO2, the carbon dioxide, is released and the H2, that is water molecules, are formed. Okay, so that's why this is to understand this. The total mass of the system is remain constant. It remain constant over time. It not changes. Okay, and also the mass is an isolated system, can neither be created nor be destroyed, but can be transferred from one form to another. as your thermodynamic energy law, that is for the energy, here it is that for the law of conservation of mass. This in 1789, Antony Laurent Lavoisier discovered the law of conservation of mass. The continuity equation in the fluid dynamics describes that is any steady state forces, the rate at which mass leaves the system is equal to the rate at which mass enters into the system. So from this equation also you can understand the mass entered into the system is equal to the mass leave the system. Okay, and also some basic definition we need to know for this unit, that is fluid dynamics, that is Newton's first law of motion. It states that body at rest or uniform motion will continue to be at rest or uniform motion until and unless any external force act on it. The body at rest, it is not moving, it means that there is no motion. But also you can say that the body is continuous motion in the uniform, and till that you will not exert or apply any external force on it. Okay. So if moving body is there, just you change the direction, it moves, but it changes the direction. Okay. At body at the rest, you kick, it will move. Okay. So you have applied external force on it. If the ball is moving and you apply the force, the motion or movement is increased, the velocity is increased, and it accelerates the motion. Okay. And if the moving ball is there and you just stop it, so it will come to stop by the external force. So that is the Newton's first law of motion. You already learned in the mechanics in your first year. Already you have learned this, Newton's first law of motion. Similarly, most of example in the dynamics or motion of the body is very important to know the Newton's second law of motion. What is Newton's second law of motion? That you know that force is equal to mass into acceleration. It means that when a force is applied to an object, it's a product, it produces acceleration in the object, and the acceleration is nothing but the rate of change of velocity. What is Newton's law, second law? When a force is applied, applied, applied to an object, to an object, it produces acceleration. It produces acceleration in the object. Acceleration is nothing but rate of change of velocity. So if you write down acceleration in terms of rate of change of velocity, that is dv by dt, it is changing with respect to. Okay. Similarly, Newton's third law of motion, you know that for solving the civil engineering problem in mechanics, we also use the Newton's third law of motion. When one body exerts a force on the other body, the first body experiences a force which is equal in magnitude but opposite in direction of the force which exerted. So Newton's third law states that there is an equal and opposite reaction for every action. For every action. Okay. So to describe that, when a body, when a when one body, one body, what is the time? Moment said. Moment said, what is the time? You should go in time. When one body exerts a force, one body exerts a force on the other body, on the other body, on the other body. The first body, the first body experience a force, experience a force, experience a force which is equal in magnitude, in magnitude, but in the opposite direction. But in the opposite direction. So if you think the example, direction of the applied or exerted force, of the exerted force. Okay. So you know that if this is your wall, okay, this is your wall. The ladder is resting the wall on the floor. Okay, this is the ladder. So this ladder, it will exert a pressure, a force here, and in turn of that force, the equal force is exerted by the wall. Okay. Similarly, if you know that the example of the ball resting on the floor is not moving, the load of the ball or the weight of the ball is uh, because it is rest, that there is opposite reaction from the floor. So that's why the body is on the rest. Okay, till that external another force is not required. Weight is nothing but the mass of the object into the gravitational acceleration. There is nothing but force. W is equal to m into g. Okay, so that's why and reaction is opposite to that. So there is always an equal and opposite reaction for every action. That is the Newton's third law of motion. So this graph, if you see the tree diagram, is very well explained the Newton's law of motion. First law known as law of inertia. Moving object keep moving, and object at rest, it will be at rest till any another unbalanced force is applied to the object. This is Newton's first law. Similarly, Newton's second law expressed as a mass is equal to mass into acceleration. The more force means more acceleration. More mass means less acceleration, which will reduce the acceleration. Okay, Newton's third law, it is known as the action-reaction law. That is, that every action there is equal and opposite reaction of the same magnitude. So this is explained by graphically. You can, or in the tree diagram, you can understand it. Then the basic concept, the first law of thermodynamics, you know that the energy neither be created nor be destroyed, but it can be transferred from one form to another form. This already you are studying in your 11th, 12th class also, or maybe 10th also. This is the first law of thermodynamics. It is very important. The energy of a universe remains the same. the energy of the universe, the energy of the universe, universe remains remains same, remains same. Though it may be exchanged, though it may be exchanged, may be exchanged, may be exchanged, it may be exchanged between the system, between between the system, between the system and the surroundings, and the surroundings, and the surroundings. It can't be created or destroyed. It can't be created, can be created or destroyed. So in simple terms, you can say that in first law of thermodynamics, that is maybe called as law of conservation of energy, that is energy neither be created nor be destroyed, but it can be exchanged between one system to another system, one form to another form. Okay? In other words, the energy of the universe remains same, though it may exchange between the system and the surrounding, and it can't be created, can't be destroyed. And similarly, the second law of thermodynamics, that is state that it state that states that any spontaneous any spontaneous spontaneously spontaneously occurring occurring process process will always always lead to leads to an an escalation in the entropy. Entropy is the energy stored in the system. Entropy of the universe, of the universe. इसका एग्जाम्पल अगर हम समझने जाएं तो if you have two different rooms, okay, one is cool and another is hot, there is a wall in between, okay, one room is cool and one room is hot. I will say this room is hot, there is some temperature, here is some temperature degree Celsius, and another room is cool room, okay, here some degree Celsius, okay. So when we open this wall, what happens? The flow of energy takes place between these two, and till the temperature between the two rooms become a constant. कब तक ये एनर्जी का इंट्रोपी का चेंज होते रहेगा? कब तक होते रहेगा? जब तक दोनों रूम का टेम्परेचर एक जैसा ना हो जाए. So that is the example of second law of thermodynamics. It is stated that any spontaneously occurring process will always lead to escalation in the entropy of the universe. Okay? So it means that till it will not be equal, it will continue. और ये ऐसा हो नहीं सकता practically. But in case of room, in case of different container, you can suggest that, you can understand that. Okay, so this is nothing but your basics or prerequisite of the your fluid dynamics. You can say that these equations or these laws are nothing but they are the prerequisite for your fluid dynamics. Okay, now we will see. Uh, so you should understand these laws because the application of these laws are you can use. Okay, now we will see. Uh, the equation of motion is nothing but Newton's second law, that is force is equal to mass into acceleration. Mass into acceleration. We'll see the forces acting on the fluid mass in motion. We'll see the forces forces acting acting forces acting on on fluid mass in motion. So in dynamic of flow, we are considering the flow is due to the force. The flow is due to force. Okay. Or we can say that in dynamic of fluid or fluid dynamic, the force causing flow. We are considering the force causing flow. So which type of force is acting on your fluid mass in motion? So if you write down, you know that force is mass into acceleration. So mass into acceleration x in x direction if you consider. So there are different forces as acting on the motion of the fluid, that is Fgx plus Fpx plus Fvx plus Ftx plus Fcx. These are the different forces. They are acting on fluid mass in motion. Okay? Or in general term, you can write down MAX is equal to F of x. Okay? Fx is the force acting in the x direction of fluid mass in producing acceleration x. So Fx, if I write down, it is the force acting. You are getting what we are teaching now. आपको समझ में आ रहा है कि just you are they are moving. Okay, are you understanding? Answer from your side. You should answer. Fx is equal to the force acting in the x direction. The x direction on a fluid mass. On a fluid mass. Okay? Fluid mass m producing acceleration 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 in x direction, that is ax. Okay? And Fg, if you write down, is the gravity force gravity force of gravity we can say. Fp is the pressure force. These are the different forces acting on the fluid in the motion. Okay? Fv is the viscous force. F nu, you say this is nu. F nu is the viscous force, and Ft is the force due to turbulence. Ft is the force due to turbulence. Okay, and Fc is nothing but the force due to compressibility. Force due to compressibility. Compressibility. So these are the different forces on the acting on the fluid in motion. Okay. So from this equation, there is Fx is equal to Fgx plus Fpx plus Fv x plus Ftx into turbulence, Fcx into compressible. If fluid is assumed to be incompressible, if fluid is assumed to be incompressible, it means that there is Fc is means that Fc is not existing. Therefore, the equation 1 becomes therefore the equation 1 become equal to f of gx plus f of px plus f of mu x is the viscous force plus f of tx, and this term will not be there because there is no compressibility. The flow is incompressible. So that's why this I will write on the equation number 2. I'll write on the equation number 2. Okay. So this equation 2 is called as Reynolds equation. Called as Reynolds equation. Only 1, 2, 3, and 4 types of forces are acting. Okay. Now if you consider that if the force due to turbulence is neglected, if the force due to turbulence is neglected, the equation 2 becomes m of x is equal to fg of x plus fp of x plus f mean of x. And this is equation number 3. I will write down equation number 3. It means that there is only 3 forces we are considering that are causing a flow. And the equation 3 is called as Navier 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 Stokes equation. Navier Stokes equation. Navier Stokes equation. Okay. Equation 3, it is called as Navier Stokes equation. Okay. These are nothing but we are thinking the way which forces acting on the fluid in the motion. Okay. So there are different scientists. They are considered different types of forces in the motion. And if the force due to viscosity, further, if force the force due to viscosity, is neglected, then the equation 3 becomes, then the equation 3 becomes, that is mass into the acceleration, that's fgx plus fpx, and this is, I will write down the equation number 4, and this equation is called as equation 4 is called as Euler's equation, Okay, so it means that the Euler's considered fluid causing motion due to the pressure and due to the gravitational. And it should be noted that for 3-dimensional flow, it should be noted that equation 1 to 4 can be written for another 2 direction, that is y and z directions, by replacing x with y and z respectively. Right? So we are considering x direction, that's why we have written it in the x direction. If another direction, the flow is there in y direction, you can write down m into ay. Okay? And different scientists, they consider different types of forces, they are causing the flow. Okay? We write down the equation first. We are considering the gravity, pressure, viscosity. We are considering the turbulence force and also incompressible or compressibility. So if you consider all these, then that is the fluid at mass causing the motion due to that forces. If you remove the incompressible fluid, you remove that, then that equation 2 and that equation 2 is called a Trinidad equation. Equation 2, if you remove the turbulence force, then the only three force is considered, and that is called as Navier Stokes equation. There is gravity, pressure, and the viscosity. And if two forces are considered, that is gravity force and the pressure force, then that equation is nothing but suggested by Euler's. Suggested by Euler's. Okay. Now we'll see, because to solve the flow problem, okay, it is very difficult if number of forces we are considered large. Okay, so we will consider the Euler's equation because it resolves the complexity of the problem solving in the fluid mechanics. So we will understand from the Euler's equation first, and you can go for further. So if you, I will write down Euler's equation, equation, equation of motion, equation of motion, Euler's equation of motion. So in Euler's equation of motion, so this we will solve. So write down in Euler's. You should write down so that you can understand. In Euler's equation of motion, only forces due to gravity and pressure, forces due to gravity and pressure are taken into account, are taken into account, taken into account. Had you seen earlier the forces causing the motion? In Euler's equation, only two forces were considered, that is the gravitational force and the pressure, okay, for the equation of motion. So for that, you have to draw the figure to understand the Euler's equation of motion. Consider the small flow through the small pipe. Okay, this is a small pipe I am considering. This is the pipe, small pipe. Okay, this is the streamline or center line, you can say, whatever you can say. So we make a line. Okay. Okay. Nothing but term streamline. Okay, and the length of the pipe, the small pipe we are considering, the length of that pipe is nothing but ds, and the weight in the fluid of the small pipe considered. Draw this figure, okay? Don't sit mum. तो वो बैठने से काम नहीं चलेगा. You should write down. Okay, you should write down. Okay. So this is weight in the fluid, and here you can say the fluid entering into the system and fluid okay. So this is, I will say, again. So different colors, why I am drawing, that it should be clear to you. This is the pressure difference between the point 1 and or section 1 and section 2, you can say. This is the pressure difference between section 1 and section 2. And that is the head is denoted by dz, okay, and this fluid weight making angle theta, okay. So I will write down here. So here the circular area, if you say the small area, and the small area is nothing but dA, okay. So this is nothing but rho into dA, okay, or you can write on P into dA, P into dA. The pressure at that point, P into dA, and at this point, to write down, this is P plus rho P by rho S into ds, because there is difference in the head and the area is small area is nothing but similar, because the cross section that is not changing, the area is not changing. So P plus rho P by rho S, you have to write down, so ds by dt. So we write down this figure 1, forces on a cylindrical fluid element. This figure you have to draw, and then when we will do for this Euler's equation of motion, we can draw equation of motion. And that only we are considering the gravity, the pressure are taken into account for the motion of the fluid, and we are considering a small cylindrical fluid element. Okay, to understand the fluid in a motion due to gravity and the pressure. So pressure at one point, different at this point. Okay, that we are written here. What is that different? Rho P by rho S into ds. Okay, area is same, then cross section area is not changing. That's why dA both sides. But pressure is changing. Okay, so this figure you have to draw, and then if you write down as per the Newton's law of motion, Newton's law of motion, Newton's law of motion, Newton's law of motion. The equation in the s direction, can be written as rho into dA rho into dA ds into as. This is the mass of that into as, that is the acceleration. So this is the mass. You know that mass into acceleration is force is equal to PdA minus P plus dou P by dou S, that is difference in pressure to ds into dA plus this vertical portion. If you take the cos theta, you resolve this force. So this mass is nothing but rho g dA ds. This is the mass. To write down the vertical, the components, this is the cos theta, this is sin theta. If we take this component along the flow direction, that is plus rho g dA ds cos of theta. If I write down, this is equation number 5. Equation number 5. Okay? So this is equation number 5. So we don't have time to complete the this derivation. We'll complete tomorrow first lecture. We should join on time. We'll stop here, and tomorrow on first lecture we'll complete this course. The derivation will not complete. So just you can see here the in fluid dynamics or any dynamic problem, mostly the Newton's second law of motion is considered for solving the problems. Maybe fluid mechanics, maybe your solid mechanics, but there is motion, so we are considering the Newton's second law of motion. If you have any question, you can ask with me. Otherwise, we will stop here. Hello? Any question? आप लोग कुछ बोलते क्यों नहीं हो? इस तरह कैसे हमारा चला जाता है? You should say something. Hello? We will stop if you don't have any doubt. So thank you for joining. कुछ बच्चे ज्वाइन होकर लेफ्ट हो जाते हैं. If they have a network problem, then no show. But if you are just joining for the attendance, then no need of doing that, because all the lecture I am already sharing you on the your Google Classroom.